It's never the destination. The destination is always boring. जो भी आपकी हो destination, the destination is never, and I drew a teddy line based on this. Anyway, okay. Homework, this is 122 to 126. Okay, so now we can start with जो आपके सवाल. So if you have any questions about the previous homework, you can ask me. Happy to answer those questions if they are easy. जी करने ये नया homework है. जी. Problem 120.
And 121.
120 and 121. So what's so let's look at problem 120 before we. This is problem 120. So problem 120 says that you have to factorize a to the 6th plus b to the 6th, right? Yeah, a to the 2n and b to the 2n. So can you factor any other polynomial of the form a to the 2n, b to the 2n? So उन्होंने सवाल ये पूछा हुआ है, क्या कोई उन्होंने in general पूछा हुआ है a to the 2n plus b to the 2n को can you factorize for any other n? और उन्होंने I think किसके लिए किया हुआ है? उन्होंने जो सवाल किया हुआ है उन्होंने a to the 4th plus b to the 4th को factorize किया हुआ है already, right? In problem 119, a to the 4th and b to the 4th has already been done. So note, a to the 4th plus b to the 4th already done in problem 1.19. Already done in 119, right? So वो तो हो गया हुआ है already. Right, so now they're asking you, can you do it for any other n? N equal to 2 के लिए हो चुका है, right? तो वो पूछ रहे हैं किसी और n के लिए हो सकता है कि नहीं. And they give a hint. What's the hint they give? Yeah, a to the power 6 plus b to the power 6. So क्या ख्याल है? A to the power 6. So that's why I started with a to the power 6, b to the power 6. Okay. That I have to do it for some. So can you do it for a to the power 6? So that's a question. क्या ख्याल है? क्या? Can it be done or can it not be done?
The factorization.
Yeah. Can you factorize x cubed plus y cubed? What's the factorization of x cubed plus y cubed? Do you have any factorization?
Plus y.
X plus y.
Multiplied by x squared minus x bar plus y
Squared y minus x squared y, that's gone. So x squared y minus x squared y is gone. Minus, and then you have plus y squared x and minus y squared x. Yeah, looks good. Okay, so there you go. So you've already done the factorization for me for a to the 6th plus b to the 6th. इससे इसकी फैक्टराइजेशन कोई मुझे लिखाए ना.
x plus y whole square
इन दोनों का आपस में कोई ताल्लुक़ नज़र आ रहा है आपको? लेफ़्ट हैंड साइड से सिर्फ देखें. अभी राइट हैंड साइड तो पता ही नहीं है ना, तो लेफ्ट हैंड साइड से देखें. Increase the power. So what would, let me talk to Samin for a second. So agar Samin, what would be the relation between x and a if one had to map to another? x क्या हो रहा है वहाँ पे? Cubed. What is a? A to the power 6. What's the relation between x and a?
This is like
A.
A is x raised to the power 3 raised to the power 2.
No, x is, if I were to replace x by something and y by something, it would convert to the left hand side. So what should I take x and convert it to? X is equal to what? A what? No. If I say x is a raised to the power 6, then a raised to the power 6 raised to the power 3 will become a raised to the power 18. बेटी मैंने आपसे पूछा, did I ask you? वो भी हाथ खड़ा कर रहे थे, वो भी हाथ खड़ा कर रहे थे, मैंने उनको इग्नोर क्यों किया था? क्योंकि I was talking to somebody. So you should always wait. So if you were to replace यहाँ पे, if you were to replace x by a squared, you see, if x is a squared, so then this is a squared raised to the power 3. What's a squared raised to the power 3? That's what you get over there. Similarly, if you replace y by b squared, what do you get? So now everywhere in this factorization, if you were to replace x by a squared and y by b squared, you'd get the factorization of a to the 6th plus b to the 6th. Right? Is it clear? So just have to replace x by, so set x is equal to a squared and y is equal to b squared, and you are done.
Sir, but this is only for a to the power 6 plus b to the power 6.
Yes.
When we have to factor a to the
What's the question? Have you read the question?
you have to factor
What is the question?
in the form.
What is the question?
So
Can you read the question for us to enlighten us with the question?
can you factor any other polynomial of the factor of the form a to the power of, to the power 2n plus b to the power of 2?
Okay, so can you factor any polynomial of this form?
Yes.
Yes, so you answered it. Right? Which one? Well, a to the 6th plus b to the 6th. A to the 6th plus b to the 6th can be factored. Here is the explicit factorization of a to the 6th plus b to the 6th. So you're done. That's the answer to the question. Now you could try to generalize it, और आपको amuse अगर आपने आपको करना हो, whenever you feel bored and you want to amuse yourself, so you can try to generalize, can I do better than this? एक example ये बड़ा आसान हो गया. Can I factorize, are all, so there's another question जो पूछा नहीं हुआ, but you can amuse yourself with it जब आप अकेले में बैठकर बोर हो रहे हो, तो is that true that every polynomial of this form can be factored for all integers n? I don't know the answer to the question. सवाल समझ आ गया आपको? हमने सिर्फ एक एग्जांपल किए थे ना, a to the 6th plus b to the 6th. Is a to the 8th plus b to the 8th factorizable? Is a to the 10th plus b to the 10th factorizable? Is a to the 12th plus b to the 12th factorizable? And so on and so forth. Is it clear? So you can ask yourself this question and you can try to answer it yourself too. ठीक है ना? Okay? ठीक है ना? But that's for your amusement. लेकिन हमारा सवाल यहाँ पे हो जाता है.
Sir,
जी.
don't you have to explicitly factorize?
I've already done it. What's the explicit factors? Can you tell me the explicit factors of a to the 6th plus b to the 6th? Plus,
A squared
plus
a squared to the power of
a squared plus b squared, a to the 4th minus a squared b squared plus b to the 4th is the factorization of a to the 6th plus b to the 6th. It's already been done. Okay? Okay, so 120 is done. Okay, but you have a question about 121, right? Okay, 121 is a kind of interesting question. this was 121 is how do you define numbers. It's actually a very important way how mathematicians now in modern algebra define numbers. So हमने जिस तरह जब fractions शुरू की थी, right? So how did we start fractions? We started fractions by looking at pizza slices. बचपन में जब आप छोटे थे तो pizza slices और इस तरह की चीज़ें, chocolate bars और pizza slices और इसको काट के apples को काट के आप बात कर रहे थे fractions. The modern way of thinking about fractions is kind of different. So they look at as you want a solution to polynomial equations. So that's the kind of thing that you will think about. So if you have two numbers p and q, so px minus q, where p and q are whole numbers. So pq whole numbers. So मैं आपको वैसे बता रहा हूँ. So this is an algebraic equation with natural numbers as coefficients. And now, what's the solution to this equation? The solution to the equation is a new number. मैं fractions define कर रहा हूँ. The solution to this equation is the fraction q over p. Okay? That's how you define fractions, modern terms. Okay, it's a weird way of defining fractions. So numbers are defined as solutions to numbers are defined as solutions to algebraic equations, as defined as, ये आपके लिए ज़रूरी नहीं है, solutions to algebraic equations, to algebraic equations. Okay? So for example, px minus q equal to 0, where p, q are natural numbers, then the solution is, so x naught, जो x naught होगा, x naught, which we will define by, जो हमने अगर करना हो, x naught equal to q over p, जो हम इसको normally कहेंगे x naught equal to q over p solves this equation, would be considered a new number that we have defined. Using natural numbers, we have defined fractions by considering algebraic equations and looking at solutions of algebraic equations. ये बात किसी को समझ आई है कि नहीं समझ आई? Oh, ignore this. It doesn't. The subscripts are just ways to making it more concrete. Okay, I want to define 2 over 3. What is 2 over 3? Yeah, 3 over 2. Let's define 3 over 2. So 2x minus 3. The solution to the equation 2x minus 3 equal to 0 is defined to be the number 3 over 2. That's how it is going. 3 over 2 solves this equation, right? ये तो हर एक agree करता है ना कि x equal to 3 over 2 will solve this equation. Yes? That's not hard, right? 2 multiplied by 3 over 2 is 3, 3 minus 3 is 0. So x equal to 3 over 2 solves this equation. But this is now defining a new number. अगर आपके पास 3 over 2 ना हो, so how would you define 3 over 2? You would say it's a solution to this equation. That's a different way of thinking about fractions. Okay? Now this may not be obvious to you. Why are we doing so? This is algebra. This is आप भी algebra पढ़ रहे हैं. But if you were to continue studying algebra in college, so let's say 8 years from अभी आप grade 9 में, so 3, 4, 4. Oh yeah, 5, 6 years from now, you still want to study algebra. So this is the kind of stuff that you will be studying. That how do you define new numbers? These are called rings, or rings के अंदर you can define other things, and there are lots of other stuff that happens in algebra, okay, later on. But this is one way of defining new numbers, okay. Now similarly, so ये तो ठीक हो गया. So ये सब हो गए. अगर आप इसको 2x plus 3 कर लेंगे तो you will start to define negative fractions, right? So the negative fractions will start to get defined this way. So you can define all positive and negative fractions this way. But now you start to come up with things like this. What's the solution to this? What's the solution to x squared plus 1 equal to 0? Well, you don't have a solution. Like you can't square a number, add 1 to it and get 0. We don't have a number like that, right? कोई ऐसा number है जिसको square करें and then you add 1 to it, you get 0? There's no such number, right? So then mathematicians say, aha, but there is such a number. And this number is going to be called the square root of minus 1. Now your teacher told you that the square root of negative numbers is not defined. But mathematicians go ahead, and it's a very useful way of thinking about numbers. It turns out that using x to be the square root of minus 1, now you can see x squared kya hoga? Minus 1. So minus 1 plus 1 is equal to 0. So x being the square root of minus 1 solves this equation. Okay? Now what is this number? I don't know what it means. And then the question arises, what does 1 plus the square root of minus 1? Well, that just stays as 1 plus the square root of minus 1, because I can't add 1 to the square root of minus 1. That's how we maintain it. Achha, now you may think it's really stupid and mathematicians don't have, उनके पास वक्त बहुत ज़ाया करने को है, so that is what they end up doing, कि they end up defining these silly numbers. Actually, a lot of what you do, a lot of the modern telecommunications would be based on playing around with this number. So a lot of the electromagnetic theory, जिस पे आपके बेस करके आपके सारे modern cell phones वगैरह और सारी satellite communications वगैरह जो काम करती हैं, is based on doing electromagnetism using this silly little number square root of minus 1. जो है, the square root of minus 1 is a very useful and effective number in real life in terms of engineering and what you want to do. But now we have defined a new number using the same idea. जिस तरह हमने rational numbers define किए थे, इसी तरह हमने, these are called imaginary numbers. So these are called imaginary numbers, या इनको complex numbers कहते हैं. And if you feel uncomfortable with them, you have joined a very reasonable, and this is called pure imaginary. So this is called just an imaginary number. So a complex number is the sum of a real number and an imaginary number. This is purely imaginary. Okay. Now, आजकल modern way of thinking about it is that it is no more imaginary than any other number. So where did you see number 3? Last time कब मिले थे आपकी मुलाकात हुई थी number 3 से आपकी? कब नहीं हुई? बुक में होती है, दिमाग में होती है, that's it, right? और तो कहीं नहीं मिले. Number 3 को मिले, 1 को, 14, किसी को नहीं मिले. So it's unreal. 14 is an unreal number, right? It's not a real number. It's in your head. It's nowhere to be found, right? I have one chalk, but I don't have a 1. 1 is in my head, right? That's all that there is to it. So, yeah, we did. And now, square root of minus 1. Did you meet the square root of minus 1 yesterday? Played hockey with him? No? It's also in your head. But let me just wrap up. So it also is effective. So why is 1 a good number? Because I can take a chalk and add another chalk, and I get 2 chalks, and everybody agrees I got 2 chalks. That's why 1 is a good abstraction to work with. Similarly, why is the square root of minus 1 a good number? Because when you do electromagnetic theory, you can do some very effective things with waves, and it does very good things for you. So that's as real as 1. So modern तरीका सोचने का ये मैं आपको 1 मिनट बाद. So that's how you think about numbers. So they are very abstract things that exist because they have some effective utility in the real world, right? That's all that there is to it. So being uncomfortable with this, you would, आपको पता है कि right up to, I think I would not be incorrect in saying कि right, I could be like slightly wrong, हो सकता हूँ, I could get the centuries off, but right up to the like maybe the 16th or the 17th, maybe even later, 17th, 18th centuries tak, people did not believe in negative numbers. Mathematicians refused to believe in negative numbers. So minus 3 they said is not a number. They did not like minus 3. They said it's a terrible number, it cannot be a part of mathematics. So for a long time people felt very uncomfortable also with imaginary numbers. They felt very uncomfortable with it कि ये क्या nonsense है. Lekin now in the modern world we have gotten very comfortable with imaginary numbers, and now they're considered as much a part of mathematics as number 1, number 2, number 3, and fractions 2 over 3 and 7 over 4 की तरह. Now the square root of minus 1 is considered very much a part of mathematics. जी आपका सवाल था.
Sir, wouldn't every number be an imaginary number?
Not every, so this would not be considered an imaginary number. Imaginary not as in the square root of minus. So there's a technical thing. Whenever you involve the square root of a negative number, then it's called an imaginary number. Although in my way of saying every number is imaginary because it's only in your head, it's never something that you can touch and feel. That is true. लेकिन इनको technically इनको imaginary, that's actually a technical name. Fractions की तरह, it's a technical name, imaginary numbers.
The square root of negative numbers are always imaginary numbers.
Yeah. They're always imaginary numbers. So that's what it is about. So now I think the question, मैं सिर्फ इस पर time spend करना चाहता था कि now you should be able to do this thing. Okay, जो आपका सवाल है वो I don't think is important. The reason why I want to talk about it was because it's a different way of thinking about numbers जो आपने पहले कभी नहीं सोचा हुआ. It is how in modern mathematics numbers are defined. ठीक है, as solutions to algebraic equations. Okay. जी. You get a complex number.
So can you subtract any number and then multiply?
Yeah, you can subtract it too. It will just stay this way. 1 minus the square root of minus 1 is an imaginary number जिसको हम vectors से represent करते हैं और उसको हम utilization करते हैं. लेकिन हम आपकी 3-phase इलेक्ट्रिसिटी में जो 3-phase इलेक्ट्रिसिटी यहाँ पे चल रही है, आपकी नॉर्मल इलेक्ट्रिसिटी घरों में 3-phase मीटर्स लगे हुए हैं, उसमें भी ये इमेजिनरी नंबर्स काम आते हैं. सॉरी, ये द कॉम्प्लेक्स नंबर्स जो काम आते हैं. दैट्स ऑल अ पार्ट ऑफ how real they are depends on whether they are useful or not. जिस तरह number 2 is useful because you have 2 copies or 2 pens in front of you, that's why the number 2 is useful. इसीलिए are these complex numbers, this weird way of working, useful? Yes, because in electrical engineering and other things they turn out to be useful. And in physics, for example, they're very useful. Okay, so moving on to something new. So ये आपका hopefully the rest of the homework was reasonably, I don't know whether it was reasonably straightforward or not, but let's try to do something new. Okay. So we have this thing, अभी तक हमने, so till now we have only added, till now we have added, subtracted be same thing. So added, subtracted, multiplied polynomials. Yeah. But now we won't get a polynomial out. So when we divide polynomials, so now we want to develop the algebra of division. So now we will divide, but and division leads to something called rational expressions. जिस तरह आपको पता है कि whole numbers में when you add, subtract, multiply, you still stay within, in the integers, when you add, subtract and multiply, you stay within the ring of integers. You don't leave the integers, right? 4 minus 2 is 2, 2 minus 4 is minus 2, 2 minus 4 multiplied by 17 is minus 34. You never leave the space of integers. But as soon as you start dividing, you can leave the space of integers. 2 over 3 is no longer an integer, it's a fraction.
The solution is always the bad guy.
Yeah, it's always a bad guy. We'll all, because you need an inverse, and that's what makes algebra interesting as you grow older. So things which have inverses are very different from things that do not have inverses. So now we will divide and end up with rational expressions. Just like हम rational numbers के साथ end up करते हैं, so now we'll end up with not rational numbers, rational expressions. So no rocket science here, but just the very usual things. So बहुत सारा जो rational, so things like for example x plus x squared minus 3x cubed over 7x plus 5. That's a rational expression, right? Okay. So or x minus 1 divided by x cubed plus 14x squared would also be a rational expression. They're just two polynomials, one on top of another.
Also
Yeah, there are lots of examples. But I would suggest that you close the book down. In fact, that's a very useful thing to do. Everybody should close the book down because फ़ायदा कोई नहीं पड़ता. You get distracted by having a book open in front of you when you don't need to. You get that, you can read the book at home. That's why the book is supposed to be there. Okay? So similarly, आप ये भी कर सकते हैं. And the usual rules, because remember algebra is really a placeholder for numbers. That's what we're looking at, right? So x's and y's are just placeholders for numbers. So the usual rules apply. So the usual rules क्या हैं? So if you have a rational expression like p over q plus minus, so p and q are polynomials, r and s are polynomials, right? Plus minus r over s. So how would you do it? You would put them on a common denominator. You'd say qs, and you will have sp plus minus rq, right? That's the usual way of adding or subtracting fractions. Similarly, if you had, so ये usual चीज़ें चलेंगी. P over q multiplied by r over s would be multiply the numerators and multiply the denominators, right? And if you had to divide P over q and you wanted to divide by r over s, so which would be P over q multiplied by r over s, right? S over r. Yeah. And this is just P over q divided by r over s. So this kind of stuff is generating the algebra जो हम polynomials पर अब करने वाले हैं, और जो division हम करने वाले हैं on polynomials. Okay? ठीक है जी? All good? इसके बारे में कोई questions? So make sure that the only thing is you cannot divide. Remember, you can't divide by 0. So 1 divided by 0 is undefined. That's not a legal operation in mathematics. Okay? Similarly, you can't divide by the 0 polynomial. So for example, x minus x, which is the 0 polynomial, you can't divide by x minus x because it's a 0 polynomial. ठीक है? Is this clear? Okay. So now let's try to do some actual algebra, and आप अपनी copies में, I think it will be helpful for you to get used to the kind of algebra जो आपको करना है. So let's try to figure out this really nice expression. This is a beautiful expression. Simplify this expression. Copies में simplify this expression. Take out your copies. Start working and calculating away, and help me figure out the answer to this. So these are called continued fractions. There's a beautiful rich theory of continued fractions. थोड़ी सी शायद हम बात भी करें इसके बारे में. जी. So once you're done, so simplify. That's the idea. मैं इसलिए सिर्फ ये करवा रहा हूँ, आपको थोड़ी सी आदत पड़नी चाहिए of doing some algebra. You need, if you're doing an algebra course and you can't do algebra, then it's kind of not very useful. When does the class end? Does anybody know?
8:40.
8:40, 20 minutes. Okay, that's not too bad. जब आप कर लें इसको simplify, you'll end up with one polynomial in the numerator and one polynomial in the denominator. So you should start from here, simplify this, then simplify this, then simplify this, and you'll get the answer. And you can see you can continue this structure forever, right? इसको मैं replace कर सकता हूँ with 1 over 1 plus x and so on and so forth. very messy very quickly if you don't do neat calculations. If you don't get into the habit of writing neatly, you'll end up in trouble very quickly.
Done, sir.
Not correct. Can't be. You can't get a number out of this. You're going to get something in x's. और second चीज़ ये x है, ये 2 में किस तरह आपने convert किया? ओके और दूसरी बात मेरी सजेशन है कि या ओके अच्छा wow. So start with this expression, then work on this expression, then on this expression, and you'll get the answer. So bottom up approach hogi, because I can't simplify this because I don't know the answer to this question. I do know the answer to 1 divided by what 1 plus 1 over x is. That's easy enough to do. हो गया? Yeah, that may look reasonable. I don't know the exact answer myself, लेकिन it looks reasonable. That's all that I know.
मेरे ख्याल से मैंने पहले
की हुई है? Oh, art of problem solving में की हुई है. Yeah. Yeah, that's the same idea. जी, yeah, okay. So the way I would proceed is, first I would simplify this expression. So I'm going to do it slowly. 1 plus 1 over x. Well, that's just equal to, if you will, I can multiply the numerator and the denominator by x. So if I'll leave it here. So I'll just say 1 over x plus 1 over x, which is just equal to x over x plus 1. इसके बारे में किसी को कोई एतराज़? So I have, so 1 divided by, इसको मैंने common denominator पे किया. So this is just x plus 1 over x, x plus 1 over x. So now it is 1 divided by a polynomial. That means I have to multiply by inverting the fraction, right? So 1 divided by x plus 1 over x is 1 multiplied by x over x plus 1, which is x over x plus 1. Is this clear to everybody? Yeah? Okay. So now this part is done. So this part is now done. So now I have, oh, plus 1 नहीं किया. So अभी ये वाला part किया ना मैंने, right? So this part is done. Now I have to do this part. So now I'm going to do 1 over 1 plus x over x plus 1. That's the second part that I have to do, because I am done with this part. This part I am done. Now I am going to do this part, right? Oh, अब मैं ये part करने लगा, this part, right? मैंने 1/1 plus x कर लिया, so ये वाला part कर लिया. अब मैं 1/1 plus ये करने लगा हूँ. So now I'm going to do this part, which is going to be equal to 1 over, this is going to be x plus 1 plus x over x plus 1, which will be equal to x plus 1, thank you, I can do it myself, you don't need to tell me, over 2x plus 1. Right? So now I'm done with this part. So now the last part I have to do is 1 over 1 plus x plus 1 over 2x plus 1, which will be equal to 1 over 2x plus 1 plus x plus 1 over 2x plus 1, which will turn out to be equal to 2x plus 1 over 3x plus 2. Any questions about this? Something which is not clear? किसी को कोई चीज़ समझ ना आ रही हो बेटे? हाँ, yeah. Any part of the algebra which is not clear? All good? Any questions? I'm going to erase it. So that's why I'm asking अगर कोई और कुछ कोई सवाल हो किसी का. All good? Okay. So let's try to do something which is a bit more interesting, and let's try to simplify x minus a multiplied by x minus b over c minus a, c minus b, c minus a, c minus b, plus I think ये b हो जाएगा, x b c को मुझे चेंज करना है, प्लस x minus a, x minus c over b c, b minus a, b minus c, plus x minus b, x minus c over a minus b, a minus c. Let's see whether I have it right. A minus b, a minus c, x minus b, x minus b, x minus a. X minus b, x minus a minus c, a minus b, x minus c, x minus a, b minus a, b minus c. I think, let me just look for 1 second. X minus b, x minus c. ठीक, all good. Yeah. Okay. Start simplifying. Calculate away. So it's a discipline of learning how to calculate neatly. It's a very important discipline. So how will you start?
You simplify the denominator.
How do you simplify the denominator? For two fractions and add them together and see what you can do. Yeah, that's what you should do. Add two fractions first. Don't add three fractions at the same time. You could, but I think adding two fractions might make life easier. or you could do 3 fractions at the same time too, everything. So now learn to write cleanly and neatly. ये मैं मैं सिर्फ इसलिए आपको ये सवाल करवा रहा हूँ. It's a boring question in some sense. बाद में there's going to be an interesting part to it. लेकिन the important thing is so that you can calculate cleanly. Okay? You can't miss a sign. You can't miss a coefficient. You make a mistake and you're dead because things will not simplify. So you have to calculate very, very neatly. Calculate slowly, get into the habit of calculating slowly, cleanly and neatly. एंड कंप्लीट क्लास वर्क. जो रह गया है, जो आपकी कैलकुलेशन रह जाएगी, वो घर जाके कंप्लीट कर लीजिएगा. ठीक है ना? सो डू कंप्लीट दिस कैलकुलेशन. इट्स एन इम्पॉर्टेंट कैलकुलेशन टू डू इट स्लोली. नाउ दिस कैलकुलेशन इज़ डन इन द बुक. यू कैन कॉपी इट इफ़ यू वांटेड टू. ओके, बट दैट वुड बी अ सिली थिंग टू डू बिकॉज यू विल नॉट लर्न हाउ टू कैलकुलेट. ठीक है ना? तो ज़िंदगी में कैलकुलेट करना इज़ अ वेरी इंपॉर्टेंट पार्ट ऑफ वॉट यू आर लर्निंग हाउ टू डू. So you should be able to do calculations very cleanly and simply. Excuse me. Okay, as you are calculating away, we haven't really started the calculation. Have you started the calculation? Okay, so as you are calculating away, बेटे बाद में कर लीजिएगा calculation. ये calculation अकेले में करने की है. लाइक क्लास में मकसद ये था आपको शुरू करवाने का कि आपको मैं सिर्फ समझाना चाह रहा हूँ कि अभी ना कैलकुलेशन करें और वेट. सो पुट योर पेन्स डाउन इस वक्त. यू आर थिंकिंग. So calculation is so there are two parts to mathematics, right? There's a calculation part and there's a thinking part. So दो काम होते हैं. So ये calculation आपको, and I would very strongly urge you कि आपको ये आनी चाहिए करना, calculate करना, okay? So that means कि आपको अकेले में बैठकर सुकून से without using the book, do this calculation yourself once and make sure you get all the signs and everything right. कोई साइन गलत हो जाएगा, कोई टर्म मिस हो जाएगी, ये तमाम चीज़ें होंगी. पहली बार आप करेंगे, you will probably end up making a mistake. Go back and recheck it. Don't compare it to the book. जस्ट खुद रीचेक करते जाएं, इवेंचुअली द आंसर विल टर्न आउट टू बी इक्वल टू समथिंग वेरी सिंपल, ओके, रियली सिंपल. लेकिन आई वॉन्ट यू टू रियली कैलकुलेट इट योर सेल्फ एंड सी हाउ इट वर्क्स. ओके, दैट्स हाउ actual mathematics will work. You will encounter something and you don't know what the answer is, and you will just be working with it and seeing कि कहाँ पे पहुँचते हैं. So this is a very strong urge कि ये आपने complete करनी है calculation खुद, ठीक है ना. So मकसद ये again, it's not कि होगा ये कि जब आप homework partial करते हैं ना तो उसका impact कहाँ पर होता है? Obviously आपकी learning पर होता है, right? और जब आप होमवर्क पूरा नहीं करते तो उसका जब आपकी लर्निंग पार्शियल होती है तो उसका इम्पैक्ट कहाँ पर होता है? एग्ज़ाम्स पर जाके इम्पैक्ट होता है. दैट्स हाउ इट गोज़, राइट. सो योर होमवर्क इज़ ऑल, आपका जो एग्ज़ाम है इज़ अ रिफ्लेक्शन ऑफ हाउ मच एक्चुअल होमवर्क यू हैव डन. दैट्स रफली व्हाट इट मीन्स. सो नाउ सो ये मैं यहाँ पे छोड़ रहा हूँ, मैं यहाँ पे आ रहा हूँ कि दिस इज़ अ फन क्वेश्चन टू म्यूज़ अबाउट. इसका स्ट्रक्चर, सो व्हाट डू यू थिंक अबाउट दिस? दिस इज़ अ क्वेश्चन जिसका मैं आंसर नहीं दूंगा, लेकिन मैं आपके व्यूज़ और राय जानना चाहता हूँ इस सवाल के बारे में, क्योंकि ये सवाल चलता रहेगा. मेरे पास जवाब तो नहीं है, लेकिन आपसे मैं सवाल पूछता रहूँगा. सो व्हाट डू यू थिंक? दिस इज़ अ होमवर्क प्रॉब्लम. No, it was given last time, this homework problem. I am sure you have thought a lot about this problem. जी, problem 96. आप सोच कर आपका बड़ा टाइम इस पर स्पेंड हुआ है, राइट? जी.
Sir, in order to get the zero polynomial, one of the polynomial has to be equal to 0.
Why? That's a question. Can you वो पूछ रहे हैं, आप कह रहे हैं कि है तो burden of proof आप पर है.
Sir, because you can only get 0.
Why?
Multiplying.
Why is the question? 2 minus 2 is 0. So why is it कि polynomials के अंदर cancellation होकर आखिर में 0 नहीं बन जाता? क्योंकि clearly आपने एक example देखा हुआ है, मैं बेटे आप पास आता हूँ, कि you can take longer polynomials, multiply them and get shorter polynomials, right? ये example आपके पास है, right? I mean that was an example in the book. I don't know, इससे पहले एक example है in the book जिसमें you take long polynomials, multiply them and you get short polynomials, right? तो कौन सी problem है? जी, आपको मैंने देखने को नहीं कहा बेटे, आपको मैंने कहा है, सजेस्ट किया देखने को, मैं खुद देख रहा हूँ. थैंक यू. लेट मी लुक, जस्ट वेट 1 second. सो इन प्रॉब्लम I'll just find it in a second, which is problem 98, right? So problem 98 में he shows you, so this is problem 98. So in problem 98 he shows you that x square plus 2xy plus 2y squared multiplied by x squared minus 2xy plus 2y squared turns out to be equal to x to the fourth plus 4y to the fourth, right? That's problem 98. So that means long polynomials multiply to give you short polynomials. हो सकता है, right? Is it possible कि long polynomials multiply to give you the zero polynomial? That's the question. जी, आप कुछ कहना चाहते हैं?
The problem 91 we done.
96, 91?
The problem 90. When we done 1 plus x square plus x cube whole square, we get 1 plus 2x plus 3x plus 4x.
Right.
Then
Yeah.
So when we will answer the similar term, we will left the 4.
We will?
Left the 4 in the middle.
Sorry, I don't understand. आप क्या कह रहे हैं, मुझे कुछ समझ नहीं आई. वो जो प्रॉब्लम थी उसमें आप 1 plus x plus किसी को मल्टीप्लाई कर रहे थे. सो ओके, ठीक है. फिर सो जब कर रहे थे मल्टीप्लाई, यू गॉट 1 plus 2x plus श्योर, तो उससे क्या, उसका इससे क्या ताल्लुक है?
फिर जब हम देखा सिमिलर टू पॉलीनॉमियल्स को मल्टीप्लाई हो रहा है, सिमिलर टर्म्स कट ऑफ हो जाते हैं, लेकिन मिडिल टर्म 4 वो बच जाती है, तो 0 नहीं होगा.
वो उसमें कट ऑफ नहीं, उसमें कट ऑफ सारी तो नहीं हो रही थी, उसमें तो बहुत सारी बच रही थी. एक एग्जांपल से किस तरह आप जनरली प्रूव कर सकते हैं? इट डजंट मेक इवन सेंस टू टॉक अबाउट वन एग्जांपल, राइट? तो आपने इसके बारे में क्या सोचा, क्या है, हाउ वुड यू टैकल दिस प्रॉब्लम? कोई आइडियाज़ तो होंगे, इतने अक्लमंद लोग इतनी मेहनत कर रहे हैं, कुछ ना कुछ तो निकला होगा उसमें से। क्या ख्याल है आपका? किसी ने कभी डूडल करने की कोशिश की है? इसको ट्राई करें ज़ीरो पॉलिनोमियल हासिल करने की। थिंक सो, ट्राई। सो आपने क्या किया घर बैठ के? मक्खियाँ मारते रहें। 7 लोग मक्खियाँ मकतब में मारेंगे तो बड़ा फ़ायदा होगा, मक्खियाँ कम हो जाएंगी। आप लोग घरों में मारेंगे, लाहौर में मक्खियाँ कम हो जाएंगी। दैट्स अ वेरी गुड थिंग टू डू। क्या किया आप लोगों ने? कुछ सवाल का कुछ सोचा तो होगा जवाब, राइट? कुछ एफर्ट तो की होगी ना। क्या चीज़ में समझ नहीं आ रही? 2 पॉलिनोमियल्स को मल्टीप्लाई करें, क्या ज़ीरो आंसर आ सकता है ज़ीरो पॉलिनोमियल के? नहीं। दैट्स अ क्वेश्चन। सारी टर्म्स कैंसिल हो जाए और आखिर में इक्वल टू ज़ीरो आ जाए, हो सकता है या नहीं हो सकता? क्यों होना चाहिए? सवाल तो ये है, वाई डज इट हैव टू बी ज़ीरो इज़ अ क्वेश्चन। जी, अगर ज़ीरो होगा फिर तो ज़ीरो मिल जाएगा, लेकिन क्या कोई और पॉलिनोमियल एग्जिस्ट कर सकता है जिसको मल्टीप्लाई करें और ना हो? नॉन ज़ीरो पॉलिनोमियल्स को मल्टीप्लाई करके ज़ीरो कर सकते हैं कि नहीं? तो आप ज़ीरो पॉलिनोमियल की बात कर रहे हैं मेरे साथ। x माइनस एक्स इज़ अ ज़ीरो पॉलिनोमियल। मैं कह रहा हूँ नॉन ज़ीरो पॉलिनोमियल मल्टीप्लाई हो सकता है। आप कहते हैं नहीं। मैं पूछता हूँ क्यों? आप कहते हैं नहीं, यही हो सकता है। ये तो जवाब ना हुआ, राइट? तो यानी कि आपने कोशिश की है टू जनरेट द ज़ीरो पॉलिनोमियल। हाउ अबाउट यू ट्राई, गो होम एंड ट्राई एंड सी व्हाई यू कैन डू इट और व्हाई यू कांट डू इट। कोशिश करके देखें। Can you find 2 polynomials that you multiply to get the zero polynomial? Okay, so again मैं आपको जो चीज़ बता रहा हूँ कि मैंने आपको पहले भी कहा था कि unless you really want to grab mathematics with both hands, mathematics is not, कोई भी चीज़ आसान नहीं होती रही, right? Nothing is easy. सो अगर आप इस सवाल पे अगर कुछ घंटे स्पेंड करने को तैयार नहीं हैं तो देन यू शुड हैंग योर हैट, बूट उतारें और साइड लाइन पे जाके बैठ जाएं। आप हॉकी खेलने के काबिल नहीं हैं। दैट इज़ हाउ इट इज़। हॉकी खेलने के लिए स्टैमिना चाहिए होता है ना, भागना चाहिए होता है। अगर आप भागने को तैयार नहीं है तो हॉकी नहीं खेल सकते। अगर आप इसके साथ 1-2 घंटे रेसलिंग करने को तैयार नहीं हैं तो इसका मतलब है आप मैथमेटिक्स की गेम नहीं खेल सकते। क्विट, गो होम अगर नहीं करना काम। ओके, सो दिस इज़ वेयर थिंग्स स्टैंड कि आपको रियली मुझे वो नहीं चीज़ नज़र आ रही कि जहाँ पे मुश्किल सवाल आता है वहाँ पे मुझे मिलता नहीं हुआ। दैट इज़ द आंसर दैट आई गेट। और नहीं हुआ ऐसा सिली सा नहीं हुआ मिलता जिसमें कुछ एफर्ट नहीं नज़र आता कि नहीं हुआ का कोई पीछे जान है उस नहीं हुआ के पीछे। करना इंपॉर्टेंट नहीं है, एफ़र्ट इंपॉर्टेंट है। एफ़र्ट नज़र आनी चाहिए कि एफ़र्ट हुई है। ये देखा नहीं हुआ, ये तो बहुत आसान है। ये वाला सवाल कोई इस तरह का सवाल है, ये वाला सवाल हो जाएगा 2x प्लस सॉरी ये सवाल है तो ये हो जाएगा, क्या होगा 2x प्लस 1 होल स्क्वायर। ये सवाल हो जाएगा, इसको फैक्टराइज करना हो जाएगा, राइट? ये सवाल सारे फैक्टराइज करके ले आएंगे कि ये होमवर्क हो गया जी, ये होमवर्क हो गया, दिस इज़ द होमवर्क। वाओ, वेरी इंप्रेसिव। ओके, सो अगर आपने ये वाले सवाल हल करने हैं तो देन यू शुडंट बी डूइंग गेल्फांड्स अलजेब्रा, देन यू शुड बी डूइंग रेगुलर ओ लेवल मैथ। अगर आपने ये वाला काम करना है ना तो ये ओ लेवल मैथ में बहुत आपको करवाएंगे, सारा वक्त यही करवाते रहेंगे, आप कर करके पागल हो जाएंगे। ये काम करना है, अगर आपने काम करना है तो ये वाला काम करने वाला काम है। ओके, इसी तरह ये वाला काम करने वाला काम है। कुछ सवाल होते हैं जो करने वाले होते हैं, जिस तरह हमारा फ्रैक्शंस वाला सवाल था, नेबर फ्रैक्शन वाला सवाल था जो करने वाला था। कुछ सवाल होते हैं जो करने के काबिल होते हैं, और कुछ सवाल होते हैं जो आपको सिर्फ तैयार कर रहे होते हैं कि आप कुछ बेहतर स्टैमिना बिल्ड कर सकें। लेकिन असल मैच आपका यहाँ पर पढ़ा है जाके, दिस इज़ नाउ द मैच। या कुछ है इसमें सवाल हैं जिसमें आपका कुछ मैच पड़ेगा. ओके, सो दैट इज़ वेयर यू वांट टू इन्वेस्ट ऑल योर एनर्जीज एंड टाइम इनटू इट. और उसको आप कई तरीक़ों से टैकल करने की कोशिश कर सकते हैं, लेकिन वो टैकल करना नज़र आना चाहिए. यहाँ पे तो कुछ नज़र ही नहीं आता. यहाँ पे होता है जी नहीं हुआ, राइट, ओके, आई लेट यू गो, मुझे तो कोई फ़र्क नहीं पड़ रहा, राइट, मैं तो आपको ग्रेड करके निकाल दूंगा, दैट्स फाइन, दैट्स ऑल दैट विल हैपन. मैं ग्रेड कर दूंगा एंड यू विल गेट डन विद वट एवर, राइट. आई मीन मिड टर्म में आपने हाल देखा हुआ है, और अभी मिड टर्म आसान था. अभी मिड टर्म मैंने आपको बताया था, मिड टर्म के बाद चीज़ें मुश्किल होंगी. ये पहला आपका इंटरेस्टिंग होमवर्क है जो आपको मिला है अभी तक. दिस इज़ द फर्स्ट इंटरेस्टिंग होमवर्क दैट यू हैव. सो चीज़ें मुश्किल होती हैं. तो आप लोगों को जो गेलफांड के अलजेब्रा पढ़ने के शौकीन हैं, तो वो शौकीन हैं. शौकीन वो होता है जिसको शौक़ होता है, राइट. शौकीन वो नहीं होता जो मजबूरी के मारे काम कर रहा होता है. ए वेरी डिफरेंट वे ऑफ थिंकिंग अबाउट द प्रॉब्लम. ओ लेवल मजबूरी है, ग्रेड लेना उसमें मजबूरी है. गेलफांड शौक़ है. दो फ़र्क चीज़ें, दे नॉट द सेम थिंग, राइट. शौक़ पालना एक और चीज़ होती है, मजबूरी एक और चीज़ होती है. ओ लेवल का ग्रेड मजबूरी होती है, गेलफांड का शौक़ होता है. आई एम डन. आई एम जस्ट गिविंग देम अ